Everyone, so I want to introduce my instant ice experiment that I'm about to do with you all, and I just want to go over a few important topics before I show you guys because I don't know if the experiment is going to work or fail, so I just wanted to kind of elaborate on it a little bit beforehand. So it's important to note that ice has less energy than water in its liquid state. So frozen water, ice, has less energy than water molecules as a liquid because when it's ice, it's lost heat energy. They say that when you do the experiment and you tap the bottle, it's supposed to kind of allow an instant freezing and almost like a slush compound to a slushy consistency to form. And I think this is because as these crystals start to form in certain areas of the bottle where there's an impurity or, if you have it a certain way, there might be a gap in space, stuff like that. I think that's because as these crystals have to kind of adhere to each other, some of the other water will have to warm up as energy is released from those. So when water is cooled to the freezing point, crystals will form, and these crystals need something to latch onto in order to form like a full ice substance, essentially. So what I'm thinking is that when I have the bottles kind of leaning horizontally, so I'm thinking that maybe when I take them out, those crystals would have formed on wherever there may not be water hitting the plastic of the bottle. So I'm excited to see that. And keeping the water frozen, I didn't freeze it for a super long time, so it shouldn't be rock solid yet. But having that super cool temperature should speed up the crystallization process, and then the tapping of the bottle should increase the energy needed for those ice crystals to come together, stick together, and form ice. Additionally, like I said, it shouldn't be solid ice. It should be able to pour out almost like a slushy material upon pouring, but I don't know if it's going to work. I'm going to try it in coming out of the bottle, tapping that bottle, seeing what happens, and then I'm going to try to get some ice from my freezer and pour it on and see if I can grow my ice cubes a little bit. So after watching the video, I want to read a little bit more about it, try to understand the physical properties that were taking place. And it's something that I always like to stay optimistic that projects are going to work. This one, I'm not too sure, but we're going to see what happens. My bottles are still currently chilling in the freezer. I'm hoping they're not rock solid yet. It's been about 3 hours. So let's see what happens and see if the snap freezing phenomenon works for me. Thank you. Hi everyone, welcome back. I switched my filming angle, so I hope it's easier to see. After filming the video, I just grabbed my 2 water bottles out of the freezer. One froze significantly more than the other. So this one is definitely more liquefied than this one. I also grabbed a metal bowl to see what would happen if I poured some liquid and stuck an ice cube in it. And then I also have 3 ice cubes in here. So I'm just grabbing a paper towel right now. I'm going to put my ice cubes on that and hope they don't melt. And I want to try with this one to see what happens. There is still a little bit of liquid in here, so I'm just going to give it a quick tap. That didn't do anything, so I'm going to try banging it on my counter and see what happens. Okay, so that's actually pretty interesting because it was a little bit slushy to begin with, but I could definitely see where those gaps were, probably from the way I was laying it down. After tapping it, nothing happened, but there's still like a few spaces, so I might have just needed to freeze it for a little bit more time. But there was a space probably bigger than this one. I'm not sure if you can see it, right in the middle. So when I hit it, that space actually disappeared. So I'm going to try hitting it one more time and seeing if this gap and this gap kind of crystallize and see what happens, okay? Let's see. Okay, so one of them went away, and then there's still one on the back. So I'm going to try it one more time. Okay, no, that one's still hanging out. Okay, so now this is the more liquefied one. I'm going to give this one tap, and then I'm going to try pouring a little bit and sticking an ice cube in it. Okay, I'm going to give it one more aggressive stomp. Okay, that's actually funny because this one definitely froze more than it was originally. It definitely wasn't as frozen as that one to start. None of them were complete ice yet. But this one definitely froze a little bit more. So I'm going to take this one because it's still a little bit more liquidy. But again, the solidifying of it definitely increased a little bit. So I'm going to take some of this and pour it into this bowl and just kind of see what happens. So as you can see, I'm going to see what happens when I put the ice cube in here. So you can definitely tell that this is super duper slushy. Now I'm going to take this ice, and I think my hands might be warming it up too a little bit. So this kind of has a few like potential errors in it. I'm just sticking the ice cube in here. Okay, that didn't work. Okay, that also didn't work. Okay, so the ice cube part of this did not work. Maybe try it with this water. Let's see what happens with this one. Okay, so building that ice that was also mentioned in the video did not work for me. Personally, I think that just based on the requirements of this experiment, it could completely just be me. I think that there's a lot of room for error, such as I timed both of my bottles at the same time, and just positionally, they both came out to different solidifying rates, even though they're both pure Poland Spring unopened water. And, you know, I think that there's a lot of variables that might tie into this, such as my bowl was in a pantry. What would have happened if the bowl was colder, being a metal bowl? What was wrong with my ice, where it didn't kind of create that instant crystallization. So even though it didn't work, I think that there's learning to do to make it work. That's just my insight from doing this. I did basically what the video showed us and explained. I tried to do a little bit more of my own personal research to understand like the mechanisms and the physicalities of the experiment, but it didn't work entirely. The water definitely solidified when I put that aggressive thump on my counter. So that was interesting to see. I guess that force kind of forced the molecules to be, you know, forced together a little bit more. And then the other two parts that were mentioned in the video did not work for me, unfortunately. But I'm happy to try it again one day and kind of read more about why my experiment might have failed, and what I could do to make it more successful. So thank you for watching, and I hope you learned something from my failed experiment. Thank you.